Hello everyone and welcome to this machine learning playlist. Today we are covering an important topic, so whether you're someone who is absolute beginner or you have some experience with machine learning, this playlist has been designed in such a way that it will be easy to follow for everyone. Also packed with lots of values and information, and it will be really helpful for you, especially if you're preparing for a machine learning based job role like data analyst or data scientist. So please subscribe to the channel and drop a like below to support our work. And without any further delay, let's get started with today's topic.
Welcome back everyone. Today within this machine learning playlist, we are going to start discussing about the decision tree algorithm. This algorithm can be used for regression and classification both. But particularly for this lecture, we are going to focus on decision tree classifier. Soon on a different lecture, we are also going to cover decision tree regressor. But for the time being, our focus should be only on decision tree classifier. So get ready. Drop a like below before proceeding, subscribe to the channel if not yet subscribed, and without any further delay, let's start exploring this algorithm. So usually with this kind of problem where the classification can be done with the help of a straight line or a decision boundary like this, we can use other machine learning algorithms like logistic regression or SVM. We have already covered both of these topics within this playlist. So in case you have missed those lectures, then please consider watching those as well. So these two algorithms can simply help us to draw a decision boundary in order to segregate between two different classes. Yes, there are few data points like here, and these ones that we are misclassifying with the help of this boundary. But most of the other data points has been classified correctly. You can see that. But what if our data set looks something like this? Going by the visual representation, you can understand that it is quite not possible to do a good classification by simply drawing a straight line. And especially for these kind of cases, when we need to solve a classification problem, it is advisable to use decision tree algorithm. So let's try to understand how the algorithm actually works. What is the basic flow structure? So this data set that you can see, it is a made up data set, of course. On the x-axis, we have number of hours studied by a student per day. On the y-axis, we have a value that says that how many hours per day the student is watching TV. And going by these two values, we need to decide whether the student will fail or pass in the exam. Visually, we can understand that students who are reading more number of hours per day, most of them are actually ending up passing the exam. And students who are watching a lot of TV every day will tend to fail in their exam. But you can see there are few students who are not watching that much TV, but they are still failing. And there are few students who are watching a lot of TV per day, but still they are able to pass the exam. And therefore, the data points that we have within this entire data set are kind of mixed. And algorithms like logistic regression or SVM will not be able to resolve this for us in order to do the classification. So let's try to understand that how decision tree is actually helping us to do the classification. Going by a simple definition, decision tree are nothing but a binary tree that will keep on splitting the nodes considering a feature till the time we get the purest leaf nodes. Now it is absolutely fine if you did not understand anything from this definition, but I promise you that next time when you watch this video, you will have a full clarity around this particular definition. So let's try to decode the same. First of all, the decision tree algorithm is considering this particular feature, which is number of hours a student is studying per day, and it is defining a condition that is the student studying more than 4 hours per day. Let's see what happens when the answer is yes and what happens when the answer is no. So when a student is studying 4 hours per day, or I should say more than 4 hours per day, 30 students are passing the exam and only 2 students are failing in the exam. On the other hand, if the student is not studying more than 4 hours a day, then still around 25 students are passing, but 30 students are failing in the exam. So going by this condition, we have one clarity that if the student is studying more than 4 hours per day, there is a high chances of passing in the exam. But if the student is not studying more than 4 hours per day, then still we do not have clarity that what factors can decide whether the student will pass or fail in his exam. And here, this particular node, which is called a leaf node, is relatively pure compared to this one. So this second one will be called an impure leaf node, because this is not giving us the clarity if there is a high chances of passing or failing after going through this particular condition. So in order to purify this particular node, we split it further with this condition. If the student is watching TV more than 3 hours per day, if the answer is yes, that means the student is actually watching TV more than 3 hours per day, then we can see only 4 students are passing in the exam, but 25 students are failing. On the other hand, if the student is not watching that much of TV, more than 3 hours per day, then 21 students are able to pass in the exam and only 5 are failing in the exam. So now you can see this particular leaf node, which was impure earlier because it contained the mixed values from both the classes, after going through this particular condition is now a lot more pure compared to the previous state. And this was a very basic example to understand how the decision tree algorithm actually works. So this particular node will be called a parent node. This will be the condition, and after checking the condition, the results we obtain will be called leaf nodes. If we get a pure leaf node, then we are fine with that. If the leaf node is impure, in that case, we will try to split this further. This is the very basic idea around the decision tree algorithm. But still, you might have few valid questions in your mind that how do we decide which feature to split first? Whether we should go for number of hours studied per day or number of hours TV per day. So this is the first question, that how do we decide which feature to split first? And the second question is, let's say with this feature, number of hours studied per day, where we have continuous values like 2 hours, 3 hours, 4 hours, 6 hours, something like that. How do we decide that we want to split with 4 hours? Why did we not go with 2 hours or let's say 6 hours? How do we come up with this particular value of 4 hours? So these are the things that I will try to answer going ahead in this lecture. So please stay tuned. But prior to that, let's have another example where we are using decision tree classifier, where all the features are categorical. We do not have any continuous values over here. And then how the tree is actually working in order to do the classification. So this is a really famous data set in the field of analytics, statistics, probability. It is used a lot for explanation purpose in most of the areas. The data set has 4 features: outlook, temperature, humidity, and windy. And depending on these 4 features, we have a target variable where we need to classify between yes or no if the game should happen. Golf should be played or not. So first of all, the algorithm is considering this feature, which is outlook. And within outlook, we have 3 values: sunny, overcast, and rainy. And we can see when the outlook is overcast, the straightforward answer is yes, the game should happen. If the outlook is sunny, we have a further condition if it is windy or not. If it is windy, the value is true, then the game should not happen. If the value for windy condition is false, which means the weather is not windy, then the answer will be yes. Similarly, on the other side, where we have rainy outlook, we are checking with the humidity condition. If it is high, then game will not happen. If it is normal, then game will happen, and the answer will be yes. So this was an example where we have categorical values within our features. We have another example where we have mixture of categorical and continuous values. So these are the 4 features: outlook, wind, temperature, and storage. And within the target variable, we have sailing, and the categories are yes or no. Outlook and storage being the categorical features, wind and temperature being the continuous values. And feel free to have a look on this tree or on this algorithm to understand that how do we finally come up with yes or no values. You can see by the end the leaf nodes that we have, both of these are pure. On the left hand side, we have 0% yes and 100% no. And on the right hand side, we have 100% yes and 0% no. Which means the decision tree algorithm is defining the conditions and taking the decision so well that by the end, we are left behind with pure leaf nodes. This is something that we look forward to achieve with a classification problem that we are trying to solve with decision tree. So I would suggest that you pause the video and feel free to have a look how the algorithm is actually working here in order to split the categorical and continuous value. As I have been talking previously around pure and impure splits. So on the top, you will have your decision node, and after splitting this node, you will have these 2 leaves like this. This leaf is a typical example of a relatively pure leaf because most of the values over here, most of the data points belongs to the same class. And on the right hand side, again, we have a pure leaf node. So both these leaf nodes are pure after splitting the decision node. On the right hand side, you can see after splitting this particular decision node, both these leaf nodes are actually impure. The data points that each of these leaf node contains has a mixture from both the classes. So this one is an example of pure split, and this one being the impure split. And before we move further and understand that how do we choose a feature that can provide us this kind of pure leaf nodes, it is important that your understanding around this topic should be absolutely clear. Okay, so let's move further now. So you have a lot of confusing diagrams, mathematical formulas, and new terms like entropy, Gini impurity on your screen, which might be confusing and bothering you. But do not worry, everything is going to be simplified and explained within a couple of minutes. So measure of randomness or impurity are nothing but few techniques that helps us to understand that which feature among the entire data set we should choose first that can help us to achieve pure leaf node. And these are the different kind of methods: entropy, Gini impurity, and information gain. Let me tell you that the overall agenda for each of these methods is actually the same. Their mathematical formula is slightly different with each other, but the end goal is same for all of them. Choosing any of these techniques will help you to pick a feature that can help you provide pure leaf nodes. So these are the formulas for entropy and Gini impurity here on the top. There is no need of memorizing this formula at this point of time, as far as you understand that both of these method or any of these method is actually helping us to achieve pure leaf nodes. Information gain is something that tells us the difference between the parent node and leaf nodes after splitting. Moreover, the information gain is the term that tells you after you do the split of a parent node that how much difference you were able to achieve in terms of purity. And we will see that going further. For the time being, let's understand entropy over here. So you can see this particular node contains the mixed data points from both the classes. On the other hand, this particular leaf node looks absolutely pure because it contains the data point from only one of the class. And this being impure, we have a higher value of entropy over here. In total, we have 13 data points within this leaf node, out of which 7 data points belongs to first class and other 6 data points belongs to the second class. And we are putting these values to this particular formula over here, exactly at this place. And this is how we achieve this final value of entropy. By the way, there is no need of getting overwhelmed by all this information and all this mathematical calculation. When you are working with this decision tree classifier, you don't need to do any of these calculations manually by yourself. It is just important to have a basic understanding that how entropy works. So we have seen that when we have an impure leaf node, the value of entropy will be higher. On the other hand, where we have a pure leaf node, the value of entropy is absolutely zero. Zero denotes absolutely pure leaf node that has data points coming from one particular class only. Now let's shift your focus to the second figure on the right side. So this particular parent node has a mixture of data points coming from both the classes. And after doing the split, you can see it has become relatively purer within the leaf nodes over here. So these are not absolutely pure, but compared to the decision node, it is doing better now. So the lesser value you have for entropy, the purer the leaf node will be. Okay, we are good so far. We have understood that low entropy value will give us a pure leaf node and high entropy value will give us impure leaf nodes. Now let's say within a data set where you have 3 features like F1, F2 and F3, and there is one target variable, let's say T. The question was that how do we decide which of these features needs to be split first? And when we are using entropy, what it does is it checks with each and every feature. And let's say F2 has the lowest entropy. In that case, this particular feature will be split first. Then again, it will check the entropy with other features over here. And the feature with lowest entropy value will again be splitted further like this. And the difference in purity between the parent node and leaf node is actually called the information gain. So we have answered one of the question that how do we decide which feature should be split first. Now let's also explore the answer for the second question, which was if you have a feature with continuous values like this 2, 4, then 6, then let's say 8. Let's consider these values to be number of hours studied per day by a student. Then how do we decide that considering which value of these we should split first? Whether we should go first with students who are studying more than 4 hours per day or more than 2 hours per day. How do we decide? So we need to calculate the average of the adjacent values like this. The average value of 4 and 2 will be 3. The average value for 4 and 6 will be 5. The average value between 6 and 8 will be 7. Then entropy or Gini impurity, whichever method you are using, it will check with all of these values, more than 3 hours, more than 5 hours, more than 7 hours. And whichever of them is giving the lowest value of entropy will be considered first to split further. So I hope this part is now also clear to you. So we have covered the topic of decision tree classifier. We have understood that how it is working like a binary tree, trying to split the features further in order to achieve pure leaf nodes, using what methods it is choosing the features or values that needs to be split first, and in a nutshell, what is the flowchart for this algorithm. Now let's quickly discuss the advantages of using decision tree classifier algorithm. Yes, it is very easy to interpret and very intuitive. It performs really well with non-linear data that we have already seen. If we have a data set where the classes can be linearly separated, of course we could have gone with algorithms like SVM or logistic regression. But in cases where the data cannot be classified linearly, decision tree works really well. It can handle both categorical and numerical data. And please expect this question in interviews as well, that which are the machine learning algorithms that works really well with categorical data as well as numerical data. And the answer should be decision tree, random forest, or other bagging or boosting techniques. Decision trees can be used for classification and regression both. And of course, within this lecture, we have only explored decision tree classifier. The regression thing is yet to be explored within this playlist. It has fast training as no concept of iteration for convergence. So what do we mean when we say convergence? We have studied about loss function within this playlist, that when we are starting with random values for our parameters, let's say these, then the loss can be anywhere within this figure. The loss can be here, the loss can be here as well. And our goal is always to reduce the loss to this point, at the minimum point, from where it cannot be reduced any further. And bringing the loss from this particular point to this point like this is called the concept of convergence, where gradient descent actually helps us. By the way, if you have not yet covered the video on loss function or gradient descent, then please consider checking it out from the same playlist. The link will be there in the description box. And here we are trying to understand that this concept of convergence is not needed in case of decision tree algorithm, whether you are working with decision tree classifier or decision tree regressor, because it is not dealing with any parameters at all. The entire algorithm is working like an if-else condition, and when you are providing a new data to this algorithm, all it is checking is going by this if-else set of condition, that what should be the answer or how to classify the point. So you can be asked in your interviews as well that if the decision tree algorithm tries to converge or not, and the answer will be no. There is no concept of convergence with decision tree classifier or decision tree regressor. And finally, it is robust to missing values and outliers. Previously we have seen how other algorithms like linear regression, logistic regression, or KNN suffers due to outliers or noise within the dataset. But comparatively, decision tree in case of outliers will perform really well. Now let's also quickly cover the disadvantages as well. The algorithm is unstable. What it means is, even if there is a small change in the data, it leads to a large change in the entire structure of the tree. And this is a huge issue that we will learn how to tackle when we will cover random forest algorithm. It is not recommended for large data set. Also tends to overfit, which means sometime might not perform that well on testing data, and it is impacted by imbalanced data set. So before considering a decision tree algorithm, you need to make sure that there is no issue of imbalance within your data set. Okay, so I think that was it for today's lecture. We have seen a lot, we have covered a lot of things within this video, and now we understand how decision tree algorithm actually works and what are the advantages or disadvantages of using it. Smash the like button below if you found it useful. Also consider subscribing if not yet subscribed, and I will see you in the next lecture where we will cover a new algorithm. Thank you very much for your time.